Hi, sir.
Hi, Amy, how are you doing?
I'm good. How are you?
Good.
Good, good.
Yeah. How was the test paper? Did you have a look at it?
Yeah, a little bit tricky.
Yeah, it
I
is.
did what I could.
That is right.
Yeah, it's
So,
just graphing it. I find it really hard.
yeah, it is. The idea is that, half of it kind of what you have done, and rest of half of it is what I want to teach you further. So that way
Okay.
the question paper has been made. So I hope with this we could finally close the unit on limits. That's the whole idea, right? So that's the purpose. And my test papers are normally open book test papers. You can always have them and spend your time in solving. But while you sit down and work on this test paper, I like you to allocate an hour and see how much you can do within an hour. That is kind of important, right? In today's talk, we'll actually discuss how to attempt a test paper and get the maximum marks which you can given a test paper. So this will be our sample test paper, and we'll try to see how do we maximize our learnings. Because I've seen many brilliant students failing to get very good marks. I mean, they know so well, and at the end of the test, the only remark they have is, "I could have done better." Now, no, that is the thing is over, right? So you could have done better has no meaning, right? We all
Yeah,
understand. We all understand it. We have to perform when we were supposed to perform, and that's what it is. So that is how I look at it, and keeping knowing fully well that we could have done better, right? But at least we should have touched that peak when it was required, and that is where I think, as a mentor and a guide, I have a role to play. So while going through the test paper today, we will see how to attempt this test paper so that we can maximize our position of getting marks. Because test paper is only testing you how much marks you can get. That's the whole idea, right? So we will begin by sharing this. But before that, I would like to have your own comments. How much, there were about, I think, 15 questions in this paper. How many could you understand? How many could you not understand? And how many were kind of you could do? If keeping that
right.
in mind, can you explain the paper itself?
Um, I couldn't do three.
Okay. Okay.
Um, like I officially couldn't even like do anything.
Mm.
Others that I could attempt, but like kind of got halfway. Um, about five or six.
Okay.
Yeah, and the
So
rest are okay.
that's okay. That's very good. That's actually not bad because if you're able to do 75% of this paper, I mean, you can grade yourself as the 90 percentile, right? Because the test papers are normally not just out of 100. We have to see how most of the students are going to perform on this. So if you get 75% on this, it is kind of 90 percentile, and that's not bad actually. So let me share with you the screen, and then we'll discuss the test paper. Okay, so I think you can see the screen now.
Yeah.
Okay, so here is limits lesson 3 exam review. The very first question which I have given here is limit x approaches infinitely large value of square root of 3x minus 1 divided by square root of 5x plus 1 plus cube root of 2x plus 1. That is extremely difficult question. Now, could you get this question, or do you understand how to answer this question?
I didn't get it initially, but then I watched one of your other videos, and then
Okay, that's a good
kind
thing.
of yeah, got through.
Perfect. And that is the whole idea. See, I have hundreds of videos. Now, when I am touching upon a particular topic, I will only be discussing few examples. So rest is there for you to explore. So you have to go through, many books, many reference materials, and sometimes you can always go through my list of videos and explore how to do such questions. Perfect. So that's a good thing which you did. Now, we'll move on from question to question. And I will actually suggest in this particular case, Emmy, that whenever you get a test paper, it is a good idea to spend about first 5 minutes in going through all the questions. You understand? So
Um,
that you get an idea of what is there in the test for me to answer. Is it a very lengthy paper? Is it a very easy test paper? Is it a very difficult? It gives you a fairly good idea about what is it all, correct?
yeah,
And it also tells you, in a way, at what speed you should be answering. Because if you find that it is very lengthy and there are questions which will need more time than allocated, you will know exactly how to move around from one question to another, right?
yeah.
So instead of 5 minutes, today we are going to spend actually 20 minutes in understanding this test paper. How should it be answered, right? So be interactive with me. You need to read the question. I know when you want to scan the test paper, you could scan it in about 5 minutes. That's perfectly fine. But now we are going to analyze your scanning and develop a method of analyzing it so that when it comes in your actual exam in 5 minutes, you exactly know what to do, right? And in our next session, we will see how to solve this test paper. So in between, I'll give you time to sit and solve the test paper, and then we will discuss how to solve the test paper. So that is going to be our next meeting. So today's focus is to read the test paper, understand the questions, and then share with me what goes into your mind about answering this question and keep on moving from one question to the other. So here is the very first question for you, Emmy. I would like you to read the question and tell me about your own thinking. And as soon as you're done, I'll move on to the next question.
Okay. So evaluate limit of function f of x from graph. So, right, so the first question A says limit as x approaches -3 of f of x. So I would go to -3 from the left side.
So when you look at this question, you see a graph and you see that the limits are there and these limits are not very difficult and you can answer this, correct? This is what will come to your mind. Question number 2 is write domain and range. It gets into your mind, that is not difficult, I could do it, right?
Right.
Right. So we'll move on to the next question now. Have a look at this question.
So given f of x equals, so there's a few conditions.
Yes.
X plus 1 whole squared, where x is less than -1. X, where x is between -1 and 1,
Yes.
where they're both included. And 2x minus x squared, where x is greater than 1.
Correct. And you need to find limits at different points. What goes into your mind? How should you be solving this particular question?
So I know that we obviously have to draw a graph.
Yes.
So that will make it easier. Then you just have to approach the different values that are given.
Perfect. And while you're drawing a graph, you should also calculate the values. Graph cannot be drawn without values. And the values are helping you to answer the questions. You're getting my point?
Yeah.
Now, here is a correction in this particular part B, where I wanted to write in part B as x approaches -1 from the left side. So this is minus on the top, right? So make a change in this. We'll write minus on the top from the left side, and C is approaching -1 from the right side, correct? So now, what you're going to do here is that you will draw the x and y axis, and you know your critical points to work are -1 and +1. So you should draw a dotted line for -1 and +1, so you have a frame to work with. And for the very first question, you want to find the limit when x approaches 2. So you'll figure out where is 2 for you in your graph, and from the above, you know 2 should be 2x minus x squared. So that leg of the graph, which is x greater than 1. So substitute 2 here, you get a value, and you'll put this value on the graph itself, right? So as you read and answer, you're developing your graph side by side. By the end of answering this question, your graph will be on the side and you can check all your answers. So that will ensure that you have perfectly answered this particular question, correct? Next question. Now, this particular question gives you basic questions on evaluating limits. Now, when you look at it, what goes into your mind?
So first I would substitute the value, which is the approached value, and see if I get an actual value. If I do, then move on. If I get an indeterminate form, which is 0 over 0, then I would have to use other strategies like rationalization, factoring, simplifying.
Correct. Now, Emmy, most of the time, the rule for solving a test paper is that you start with the first question and end at the last question. And that is what most students will do. So let us say that you began with the very first question and you were very encouraged. They were very easy questions to begin with. And you now end up in this particular set of questions to find the limits. The first two are very easy, definitely. Question number 6 could be a hurdle for you for some extent, since you're not very familiar with trigonometric expressions at the moment, right? Because we're not into really trigonometry. We have been talking more about polynomials and other functions, right? So that may be tricky for you. Then question number 7, kind of difficult. 8, maybe time consuming. 9, extremely difficult. Correct?
Mm-hmm.
Now, if you are moving through without going through the whole test paper, probably you will get stuck at question number 9 and spend so much of time here that your time for attempting the paper will be almost over. By the time you realize that, very less time is left and there's halfway to go, it will be
Yeah.
too late. It will be too late. You get an idea? So normally in a test paper, there might be few hurdles in between. If you have a prior knowledge of what to, expect later on, then or you can make an attempt of skipping few questions in between. So at this stage, when you are there and when you're scanning your test paper, you should identify that there are a few questions here which I should definitely skip. Do you understand?
Yeah.
Another point which we are working on is that we are not always trying to get 100%. Our idea is to get 90-10. That means if I score more than 90%, it is perfectly fine for me. Perfect? So take a hit of 5% while moving along. Don't get stressed. So even if you get 2 questions in this set which you think are very difficult, in your mind you should say, well, it is just 5%, and I can go with that hit of 5% and let me move around. I'll leave that, right? Still, you are 90 plus. You get the idea.
Yeah.
The strategy of 90 plus keeps you motivated and on focus to answer the test paper. And I think this is a very important strategy at this moment. Otherwise, if you get stuck here, you will not even reach 75%.
Yeah.
Now let's look into the next set of questions. How do you find these questions?
So given that the limit f of x plus g of x exists, write functions f of x and g of x such that limit as x approaches 0, f of x, and limit as x approaches 0, g of x does not exist.
Yes. Can you answer this question for me?
No, this is the one I got stuck on. It was like, I don't even know where to start.
Perfect. Now let's try to understand the concepts of limits and answer this particular question. It is saying a very simple thing. Given that the limit of fx plus g of x, that means sum of 2 different functions, exists. So limit, when you add the 2 functions, exists. However, it says write function f of x and g of x such that the limit of f of x and the limit of g of x as x approaches 0 do not exist. So individually, the limit of these functions do not exist, but when you add them up, then it exists. Now can you answer the question?
So does that mean they would either be like poles or step functions? Or...
It could be 1 over x. So if I write 1 over x, then the limit does not exist when x approaches 0. Because we are specifying in this particular question that it does not exist at this particular point, which is x equals to 0. So focus on x equals to 0, go through the examples which you have already done, and reciprocal function 1 over x, the limit does not exist at x equals to 0. So that is a good example. But you have to give 2 examples. The other function could be minus 1 over x. You get the idea? So when you add them, it is 0. Now, this limit of 0 will exist. 0 is a constant. And the limit of 0 at 0 will be 0. You understand?
Yeah.
That's the beauty of the question. It comes from, understanding of the whole concept. So if you know the concept, 1 second, even while reading, you will write down the answer and then move forward. Do you understand? So this is
Right.
the stage where you kind of get a brilliant question and you have a brilliant answer. Don't miss the opportunity of nailing it right there and then move forward. Do you get the idea?
Yeah.
So this is the difficult section which I'm telling you how to do. So you have realized that we started with 1 over x as the only function where the limit does not exist at x equals to 0, right?
Mm. Yeah.
And now we have a chance of making it into 2, means minus 1 over x. When you add them up, it becomes 0. And therefore, limit of 0 is 0. 0 is a constant, a number. Perfect. You get it?
Yeah.
Right, you get it. Very good. So that is one question which I wanted you to, kind of get it, because this is a very good question for any examination, right? And it comes, right? I've actually picked up all these questions from real test papers, Amy.
All
They are
right.
not fabricated. Now, you remember when we started our unit on functions, I asked you one question, and that was, give me an example of a function which is both odd and even. Can you tell me one function which is both odd and even now?
Would it be 0?
F of x equals
F
to
of
0,
x.
yes.
All right.
It is
Okay.
x-axis, and x-axis is symmetric to the origin and is also symmetric about the y-axis. Perfect. You're
Yeah.
always working with this coordinate system. The most important system with which you are working at present is answer to many of your questions. Remember that, okay?
Okay.
Now, next question number 11. How are you going to do it?
So if limit as x approaches 3, f of x equals 2, find limit of x approaches 3 of f of x cubed minus x squared over f of x minus 5.
How will you do this question?
So what I did, so for each one, I made it as limit x minus 3, x
Yeah,
approaching 3.
perfect. Good job.
And then I put it as f of x, and then I cube the whole thing, because we
Cube
know
of
what f
2,
of x.
right? So f of
Yeah.
x is 2, right? So you 2 cube is 8, and minus x squared, x is 3, right? So 3
Right.
squared is 9, 8 minus 9 is minus 1. That is your numerator, correct? Denominator 2 minus 5, which is minus 3. And you have your answer right there, minus 1 over minus 3, which is 1 over 3, and that's your answer. Perfect?
All right. Yeah.
You understand this concept? I wanted to teach you this concept. And that's
Yeah.
why I took these questions here. And these are very important questions. Question number 12.
Question 12. Okay. Sketch a graph of a function with the following properties. Limit as x approaches minus 2 from the left side, f of x equals 3. And as limit as x approaches minus 2 from the right side, f of x equals 1.
Perfect.
And f of minus 2 is 2.
Yes. How will you sketch this graph?
Well, I just started by plotting the point minus 2, 2, and filled it in
Okay, so
as a
just
whole.
explain me. Your sketch will have what kind of a look? Graph.
I mean, that's all I got. I just plotted a point because it said f of minus 2 equals 2.
So you got 1 point, and that's a filled in circle.
Yeah.
Other two, limit approaches 3 when you're approaching minus 2 from the left side. It means what? How could you do it?
0.
At 3, you could make a hole and make a line on the left side of that 3, right?
Oh.
You could do y equals to 3, for example, which is coming from minus infinity till x equals to minus 2, and there is a hole at minus 2. It ends there. So from 3, make a hole, go left horizontally till infinity, make an arrow. So if you are approaching from the left side, as you approach minus 2 from the left side, you are approaching a value which is 3. You get the idea?
Wait, how do you know it's horizontal?
Horizontal line you can draw, correct?
How do you know that?
Pardon?
How do you know it's horizontal line?
Or you can draw any line. It is up to you. You could draw a line which is increasing or decreasing also, but going
Oh,
towards the left side. Okay.
oh, okay.
So that's up to you. Horizontal is the easiest line. So similarly, from 1, you can make a hole and move a horizontal line towards the right. And at -2, you already placed a filled in circle. So you have your graph right there. You get the idea?
So it's like three, so it's a whole
Yeah.
dot hole, and then one's going right, one's going left.
Perfect, perfect. And
Oh,
the lines going right or left could be in any direction. You could make a parabola on either side, doesn't matter. Any curve, but continuous.
oh, didn't know
Any
that.
curve. So total freedom in this particular question. You understand now?
Yeah,
So these three were difficult questions, which we answered in few minutes. Do you see that? And
yeah.
that is what is going to happen. You are going, so imagine if you would have got stuck at question number 9, you would have never reached here. And you have already got 15, 20 marks while you're moving here, right?
That's true, yeah.
So you have to skip and then get to the questions which you could do, right? Okay,
Mhm.
now we'll do the next set of 3 questions, which is the last set of questions. Explain me this. Question number 13. Read and explain.
If limit as x approaches 0, f of x over x equals 1, and g of 0 is not equal to 0, then evaluate each limit.
Correct.
So as limit x approaches 0, f of x.
Yes. So we are given the limit of the complete function f of x divided by x. And we know the limit exists and the limit is 1. However, we are interested in finding limit of f of x only. What should that be? Tell me.
You
When x
can't cross
approaches 0.
multiply, can you? No.
It is only possible if you get indeterminate form, 0 over 0.
Yeah.
Because the denominator is 0 for x equals as x approaches 0. That means the numerator has a 0 at x equals to 0. Correct? There
Yeah.
has to be a factor x there. So f of x is basically x times something else, because there is a factor x which will cancel, and
Yeah.
therefore you will have a limit of 1. Correct?
Yeah.
So you could say f of x is x times some other function, h of x. Right? When x and x cancel, then the limit of h of x is 1. You get the
Right.
idea?
Yeah.
But f of x has x in it. So individually, when we talk about this particular function, which is limit of f of x when x approaches 0, it has to be 0, because f of x is x times something, maybe 2. So 2x,
Oh, okay.
it is 0. Do you see that?
That was quite tricky. Yeah. Yeah.
But it is concept. It's a communication thinking question in your test paper, right? So it has huge marks for your understanding of the topic, right?
Okay.
So I wanted to close this chapter with a clear concept and total understanding of the topic, and that is why I had kept them till the end. But I hope now you understand what we had been talking about and why limit was such an important concept. You get the idea?
Yeah.
Now the next question, answer the next part. We know that the limit of f of x is 0. We know that limit of f of x over x when x approaches 0 is 1. Now the question is, find the limit of f of x over g of x. Remember, g of 0 is not 0. So if I substitute 0 there in the denominator, you will not get 0 in the denominator, right? So what is the limit of this particular function?
At 1?
0.
Oh,
Because
0.
f of x limit is 0 and g of x is not 0. Let it be some value 1 or 2 or 3. 0
Oh, but
divided by 3 is 0. 0 divided
oh,
by 3 is 0. Got it, right? Tricky again. However, simple if you know the concepts. These are the time savers. You understand? The question paper was designed for about an hour to give you more time on questions like 4 to 9. But rest of the questions are easy to move forward, right? You should
I'm
identify
still
these questions.
I'm still a little confused about 13A. I don't really
Okay, so
explain it
13A,
again.
once again, limit of the function exists. And when you substitute 0 for x, you'll get 0 in the denominator. That
Yeah.
means limit should not exist. But it can exist if you get indeterminate form, which is 0 over 0.
Zero.
Correct?
Yeah.
So that means the numerator should be approaching 0 also. So
Oh,
the limit of f
okay.
of x when x approaches 0 is 0. Is that clear now?
Oh, that makes sense. Yeah, yeah.
Do you get
Okay.
it? So
Yeah.
you can take it like this. I was giving you another explanation since there is another question in my mind, which could be there in your test paper, that f of x could be x times h of x. Do you understand?
Oh,
And
I get it.
we could ask you, what is the limit of h of x?
Oh
The
my
limit
God.
of h of x is 1. Do you understand?
Yeah.
I could actually write f of x is x times h of x. And instead of g of x being introduced here, I will ask you, what is the limit of h of x? You will say that is 1. Because once
Oh,
we consider x and x, we are left with h of x. And the limit of h of x was 1. You get the
one.
idea?
Yeah.
But we took another question here, dividing by another function which is not 0 at 0, but the numerator is approaching 0. So the answer is 0. 0
Mm,
could be divided by any other number except 0. Perfect?
yeah.
Got it now?
Yeah, yeah. I
Good.
actually get it.
Clear.
Yeah.
Question number 14.
Oh yeah, this one I actually got. I was quite happy. Question 14. Show that the limit as x approaches 1, absolute function x minus 1, bracket x plus 2 over x minus 1, does not exist.
Yes.
So
How did you
what
do it?
I did was, so the piecewise function thing.
Perfect. One side limits piecewise function, they will not match, and you got it.
Right.
When you do, yeah, it's a jump discontinuity. When you graph it, there's a different values, plus and minus something, and that is jump discontinuity at x equals to 1. Good job. Question number 15.
15. Right. Okay. So determine the values of a, b, and c for the function f of x equals ax squared plus bx plus c, where a is not equal to 0, that satisfies the conditions f of 0 equals 0, limit as x approaches minus 1, f of x equals 3, and limit as x approaches 2, f of x equals 6.
Yes. Could you do this question?
Yeah. So what I did was I initially, if it says it says f of 0 equals 0.
Yes.
So I just subbed in the 0 into the ax squared equation.
Perfect.
And I got c as 0.
Good. Correct.
Then so the main part of this question to unlock is that because we know that ax squared plus bx plus c is a continuous function.
Yes.
So therefore, limit x approaching minus 1 of f of x equals 3. We know f of minus 1 is 3.
Very good. You actually get a
of-
bonus point for giving this explanation in your test paper. So you
Oh.
get an extra point for communication. This particular statement is such an important statement. And if you miss this, you would have lost 0.5 marks. Brilliant.
Oh.
Yes. Next. So you have identified that there are 3 points: 0, 0, minus 1, 3, and 2, 6.
2, 6.
3 points
Yeah.
will give you 3 different equations. We need to find 3 unknowns, A, B, and C can be easily solved. Correct?
Yeah.
Perfect. That's not bad. I mean, you actually did perfectly fine on what all I actually taught you. You did all of them, right? So that's great. We'll actually look into the solution of these after you really attempt a paper, and then it'll be worthwhile for me to share with you the real answers, or, how could you attempt? I mean, not the real answer, but how could you attempt? Now,
Yeah.
I'd like to have your views about what we did today. Was it helpful? Was it useful? Or it was just waste of 30 minutes?
No, it was definitely useful. Yeah, especially in exam conditions, like you said. I never used to do that, like just quickly run through all the questions and see. But now you said it, it's good to have an idea in your head, like which are the harder questions, which are the easy ones, which are the ones I can skip really quickly. And yeah, it's definitely good to look at questions and see what stuff I need to use, or you don't even need to solve it, you just need to know what strategies that need to be used.
Correct.
which is good.
And
Yes, it was so helpful.
yes, scan the test paper and plot your map of answering this examination. This is one of the most important thing for you. You have been working so hard for this particular exam. You can't let it go.
Yeah.
You have to nail it. And yes, you know that you may not be in a position to answer all the questions. That is expected, right? That is expected. So you should also know that you could skip some questions. The idea is to approach 100. The limit is 100. We have to
Mm.
approach this value of 100, right? Not necessarily being there.
Use the limits concept.
Just leave few and move on. And then once you save your time, let's say still have 15 minutes to go, then you get back to that question number 9 and say, now I should try it. And by that time, you've already gained so much of confidence. You're through the paper
Yeah.
and peace of mind, and you'll attempt it.
Yeah,
Even
that's
for
true.
attempting a question and getting a wrong answer, you might get 50% marks. And there you nail it. You are 97%. That's
Mm.
what we are looking for. You
It's
see that?
about going in with that mindset, that you're not going to get everything right, and
Yes.
you're going to approach questions that are going to go wrong, but it's
Yes.
all right. Yeah, and don't like stop at a question that you find hard, because it's like a time waste, big time. Because there are so many questions like we just saw that I could actually do, but if I stuck on that question 9, I would never have got to them.
Yeah.
So
And remember, skipping is fun. Maths
yeah,
may not be that much of fun. Keep on skipping till you come to a comfortable zone, then
yeah,
do those questions and get back to the points where you skipped, right? So
right.
that could be an excellent strategy. Perfect. So I'd like you to now sit over your test paper, start all over
Okay.
again. Allocate now 45 minutes because you've already spent time on scanning and all those things, and see how you could do this test paper in 45 minutes. Take it like
Okay.
a real examination time, right? And we'll be back with you on actually uh, checking how you did and how we should be doing it. Perfect.
All right. Cool.
That's
Thank you
it.
so much, sir.
Right? Okay.
That was so helpful.
See you after you solve the test paper, right?
Yes, sir.
Okay then. Bye.
Bye, sir. Thanks. Hi,
Hi.
sir.
How are you doing?
I'm good. How are you?
Good, good. So, could you get a chance of going through the question paper which I had shared with you, the examination test review? On
Yeah.
how do you find it?
All right. Just a few hurdles that I came across, but yeah, I watched some of the other videos and used those concepts here.
Very good. And how did you find our earlier session on how to go through an examination test paper and how to actually attempt it?
Really helpful. Like when I get and do exams now, I know to quickly do a rough scan of the whole thing, so I get an idea of what the test paper is about. So that's a really useful tip when attempting exam questions.
Yeah, sure. So I hope that helps you. Now
Yeah.
I'll share with you the screen and we'll go through the examination test papers.
Okay.
While we are going through those test questions, I'd like you to give me your inputs as how you really solve them, right?
Okay.
And then I'll share with you my solutions. So most of the solutions will be similar to yours because you are my student after all. So let's see how it goes, okay? So
Okay.
let me share the screen with you now. That is the test paper for you. Can you see the screen?
Yes.
Perfect. So Amy, here is the exam review for you. And as you have seen in the test paper, we have questions related to limits from graph, piecewise functions limit, how to evaluate limits, how to relate limits of functions. We have examples with absolute functions and their interpretation. We might have to sketch function from the limits. And then the last question is about finding quadratic equation from given set of limits, right? So let me go through these questions one by one. In fact, I would like you to go through them and provide me with your solutions since you got about 45 minutes to solve them. So tell me, what did you do in these 45 minutes, starting with question number 1?
So with the first question A, I just looked at the graph at the point -3, and looked at it from the left side and the right side. So when you approach it from the left side, you hit the point 1.
Yeah.
Right. And then from the right side, you hit the vertical asymptote.
No.
Is that fair to say?
But right side of -3, you hit the point 1 from both the sides, since it is a hole. You don't have to go that far, right? So when you're approaching, when we say right side, very close to, arbitrarily close to, that is the meaning of limit, right? So you don't have to go that far, right? So you're on this path and you hit the same hole and the value is 1, correct? And therefore,
Right.
the limit when x approaches -3 is 1.
It's 1.
In part B, as I told you, there's a correction. We are approaching -1 from left side. So I try to put this minus here, right? Not in this one. It is in the next one. Okay, that's fine. Not in this one. Okay. So rest of the questions. Did you had any difficulty? But it's good to know your answer. For part B, what is your answer? Limit for the function when x approaches -1.
Got 3.
It should be does not exist. This is an endpoint. Since it is an endpoint, you cannot approach from the left side. Correct? Can you?
Oh, no.
No. So you can only approach from the right side. So very good question. Now, whenever you're trying to find a limit at a point, you should be in a position to approach from both the sides, the same value. Only then the limit exists, otherwise not. In this case, you can only approach from the right side. Therefore, the limit does not exist, right?
All right.
Number 1C, what is your answer? Limit of f of x when x approaches 2, minus means from the left side. Yes.
I got 0.
So when you're approaching 2 from the left side, 0 is correct answer. That is right. D. From the right side, it is?
0.
Why is 0? From the right side, you're on this curve. And so you reach this hole, which is approaching 1. So it is actually 1, not 0. Correct? Is
Okay.
that right? So the limit really does not exist at x when x approaches 2. You get an idea, right?
Wait, so when you approach the number, if you encounter other lines, then do they get hit first and then you go on to them?
Just go very close. So you want to approach 2. Just be close, close by. Right? Don't go that far. Just see this. Go from here, you are approaching left side and this is your right side. Do you understand? Very close. So very close is this point on the right. So you're on this path. You get the idea?
Oh, okay.
So don't hit the other line. No, we are not dealing with this line at all. Is that okay?
Oh, okay.
Very close. Therefore, here also -2, you are approaching from left side and right side. That means you're kind of here only, right? Do you understand?
Right. Yeah.
Go here. Perfect?
Mm-hmm. Okay.
Right. So now E and F. Limit approaching x approaching -infinity. What is the limit of the function?
I got 0.
Correct. And plus infinity.
3.
Correct. Now what is the domain of this particular function?
So domain, I got x belongs to real numbers.
Mm-hmm.
And then I got y belongs to real numbers, but y is less. Oh.
There are discontinuities in between for x. So you have to incorporate all these discontinuities. So let me share with you the solution of this particular question. Now, as you can see here in the solution very clearly, that as far as the domain is concerned, the hole is not in the domain, right? So you have to filter it out. Hole is not in the domain of the function, correct?
Right, yeah.
So only left side of -3 is in the domain, and that is why we get this part. Union means what are the other parts? Well, after this, up to the vertical asymptote is in the domain. So this portion is also in the domain. Now there's a break. In between from -2 to -1, there is a break. Nothing there, right?
Mm-hmm.
3 was your end point, right? This was your end point at -1. But after -1, it is like all numbers. So x greater than or equal to -1. Do you see how tricky it is?
Yeah.
Very complicated. It may look extremely simple. So when you see the test paper, you will find the first question like this to be extremely simple, and you'll do a lot of careless mistakes as you did. Do you see
Yeah.
that?
Yeah.
Be careful. Be careful. Now, tell me again, what is the range? Correct your answer and tell me what is the range.
So y needs to be greater than or equal to my
Yes, that is correct.
-3.
That is correct. So that is what it is, right? That is how you're going to answer this particular question. Let's move on to question number 3 now. Now, question number 3 is a piecewise function. Perfect.
Mm-hmm.
So as you move along, and now here there was a correction. -1 we were trying to approach from both the sides. This is from negative side, right? And that is from positive side. And then we'll find the limit of the function at -1. Now, when you get this kind of a function, so you got all the limits?
I mean, found trouble sketching the graph. Do you
Is
think
it?
we could do that?
Okay, so let's look into the solution and understand how to sketch the graph easily. So here is the solution where the graph is given to you on the right hand side. Perfect. Now, Amy, I would like you to explain me how will you sketch this graph from the given piecewise function, as that could be another question, right?
Right.
So explain.
So, okay. So what I did with I got the second condition where it says x and then x is between -1 and 1.
Okay.
So because it's the equal to sign, they should be filled in holes at -1 and 1.
Yes.
Then the top one, it's x plus 1 whole squared. So that's a quadratic, but it's less than -1. So you can only draw the quadratic curve going in the left-hand side direction. Yeah.
That is correct.
Like that. And then
Continue.
the last one I didn't really get. Why? So was it curved because it's minus x squared?
Okay, it's going down because it is -x squared. You could factor this. Once you factor x out, you get 2 minus x. So that graph actually will have two zeros. One at x equals to 0, the other one will be at x equals to 2. We have drawn x equals to 2 since our domain is x greater than 1, not the other part, right? In between, there is a maximum for this point. So at 1, just substitute 1 here. When I substitute 1, I get 2 times 1 as 1 minus 1. 2 minus 1 is what? 2 minus 1 is 1. And so we got this value. Is that clear to you now?
Right. Okay.
That is the value which we calculated just now. So you know the graph has to go down. The x-intercept is at 2. That is not necessary for this particular question. However, it is important, right? So you know this graph going down from this particular point. Once you have your graph in place, for which you have already calculated all the values given in the piecewise function, that helps you to check your solution, correct?
Yeah.
How do you get these values? While answering, when we say limit x approaches 2, you plug in 2 because 2 lies in the third leg, right? Third piece. 2x minus x squared, x greater than 1. That means we are looking into this particular portion, correct?
Mm-hmm.
So you will use this equation 2x minus x squared, substitute 2 for x, calculate your answer. 2 times 2 is 4, and x squared is also 4, 2 squared. 4 minus 4 is 0. So you get this point 0 right there at 2, right?
Can you find that point without subbing it in, or do you have to?
Because it is a continuous function, as you said earlier. It is a continuous function, and therefore you sub it in and get the easy, right?
Okay. Yeah.
So, and you know, the function starts at 1, moves on, in between all points, limit and the value of the function is same because it is a continuous function. So when you start describing this particular graph, you could begin by saying that all the 3 legs are continuous within their own limits. Now, whether there are discontinuities or not, it really depends on the 3 points where they overlap. And one is -1, The other one is at 1, rather 2 points, where the three pieces of your graph meet. If they meet at a point, as it does at 1, then it's continuous there, and it does not meet at -1, we have a jump discontinuity, correct? So sometimes required you could answer like that. But now, once you have your graph, you could easily answer all the questions. Either way, you could answer the questions and then make your graph side by side and check your solution. Clear?
Yeah.
So now explain me why the limit does not exist at x as x approaches -1.
Because so when you approach x, when you approach -1 from the left side,
Yes.
It equals 0.
Yes.
And when you approach -1 from the right side, it equals -1. And the two values, they're not equal, so therefore the limit does not exist.
And there's a jump discontinuity limit. One side limit is there. One side limit is there, which is different. So therefore, there is a jump discontinuity. So you could explain that part also, correct?
Right. Okay.
Why is the domain all real numbers in this particular case? There's only one hole here, and at that point, it is covered by the function in between, right? So basically, you see there's continuity, right? All values, we have a value. So it is a continuous function all throughout the domain of real numbers. So that is perfectly fine. Now, we come to the main part of limits, and these are the 6 important questions on finding limits. So I've given you a variety which you could expect in any test paper, beginning with question number 4 to 9. In question number 4, you could directly substitute the value and find the answer. In question number 5, you could do with many different strategies. Now, can you explain me what kind of strategies you utilize to solve these 6 questions?
So, question 4,
yeah.
I did substitution and I got 10. Question 5, I did change of variable.
Okay.
Then I factored, so I got 125 minus u cubed over u minus 5. Then I just factored it all out, and I got u minus 5 as common. I cancelled them, and my final value was minus 75.
Okay, great. That's correct answer.
Then question 6, is it? Yeah.
Yeah.
So we learned previously tan x equals sine x over cos x.
Correct.
Then I found a common denominator as cos x.
Perfect.
Then I took out sine x and did 1 minus cos x.
Yes.
Over cos x. And I cancelled the sine x. On the denominator, you get sine square x.
Yes.
Then I did, so it's 1 minus cos x over cos x bracket 1 minus cos square x.
Yes. And
then when you can, then the 1 minus cos square x, you can expand it into, so the denominator would be cos x bracket 1 minus cos x over 1 plus cos x. Then you can cancel the numerator and the denominator of 1 minus cos x. Then you get 1 over cos x bracket 1 plus cos x.
Yes.
Then you just sub in the 0.
Nailed it.
And you get half.
Oh, great job, Abby. That was brilliant. Next question. Question number 7.
Question 7. This was quite tricky, but what did I do? So I started off by taking the x out of the bracket. So I got x bracket 2 minus 3 over x bracket, and then on the denominator I got square root x squared bracket 9 plus 5x squared. So when x approaches minus infinity, that minus 3 over x and 5 over x squared, they almost become 0. So you can just cancel them out. Then you get, so this is the key point, where when you square root of x squared is absolute value of x.
Yes.
So you get the two values being, on the numerator you get x bracket 2 minus 3 over x over absolute value x plus, Oh no, wait, sorry. No, you get x bracket 2 minus 3 over x over minus x. So we got that because the absolute value x, you need to, because we're going minus infinity,
Yes.
it would be minus x.
Very good. That is
Then,
what I wanted to explain in my solution. You have already taken care of that.
all right, yeah, that wasn't really good.
Perfect.
Yeah, and then you get minus 2 over 3. Yeah.
Great job done once again. That's brilliant. So remember, square root of x squared is absolute value of x. When x approaches minus infinity, absolute value of x is minus x, right? So that's kind of important because students think that when you write absolute value of x, it is always a positive number, right? They're not wrong, but they always go wrong, right?
Yeah.
And that's why we put this question here. Question number 8. How did you do?
So what I did was, because we got absolute value function there, so I did the piecewise function. I found the left side and the right side, and for the left side I got -1, and the right side I got 3. So they're not equal, so therefore the limit does not exist because there's a jump discontinuity.
See, Amy, how similar our thinking is. You are exactly solving the questions the way I have solved them. Do you see that?
Right, yeah.
I did exactly the same steps, not only here. Even in the previous questions, I like to share with you. So question number 4, when you answered, you substituted x as 8 and you got square root of 100 and the answer was 10, which is square root of 100. Perfectly fine. Question number 5, 125 minus x here, you did the substitution. U equals to cube root of x and u cube is x, and then it was difference of cubes. You got the answer as minus 75. Now when you went to question number 6, trigonometric function, right? Tan x as ratio of sine and cosine, take common denominator. Now at this stage, I mean, what I normally do is I'll put all this as a different, fraction part. Do you see that? So that I'm avoiding the layer of fractions. At times, there could be 3 or 4 layers, which is very confusing. So let's be clear about it. This is like something over something. I'm writing there times 1 over that thing. So 1 over that thing. Now we start canceling as shown here. Factor out 1 minus cos square x as 1 minus cos x times 1 plus cos x. Cancel those terms. Substitute the value to get half as your answer. Correct?
That's a better layout.
Yeah. So
Less messy.
exactly.
I had too many layers.
Yeah, you had 3 layers, right? So,
Yeah.
so I will actually prefer you to lay it like this so that those multi layers are not there. It is always going to help you not only here but many other places. Calculus will be actually working with very complicated functions. You should know how to simplify them as we move along, because at the end it can be too complicated.
Yeah.
Now, so our next question, absolute value of x minus 1 should be written as the piecewise function. Then you figure out left and right limit, get your answers. They are not same, so limit does not exist. So you have to write this. Since they are not same, limit does not exist. Now, question number 9. What did you do about this?
9. So yeah, this is the one where I had to watch your video on it.
Okay.
But we started off by taking the x out of the bracket,
Yes.
and I got what you got. So square root x bracket 3 minus 1 over x, all over square root x bracket 5 plus 1 over x plus square root x, and this is the part. So we had to take the cube root of 2x plus 1 aside, because the others, they have the same, like to the power of a half.
Yes.
And the cube root is to the third. So we needed to get it so we can get the x squared, like the square root out.
Yes.
So what we had to do was we had to make that cube root 2x plus 1 into 2x plus 1 squared, square root that, not square root, but like to the 6. How do you say that?
Yes.
Yeah, to the 6, so that that is the same as the cube root one. And then as you go down, you take out x cubed, then you bring out the x 3 over 6. 3 over 6 is the same as a half, so you got square root to the 6, 4 over x plus 4 over x squared plus 1 over x cubed.
Yes.
Then you sub that whole thing back into the denominator. Then you can cancel all the square root x's, and you finally, so all the 4 over x squared and everything, because it's approaching infinity, they all become 0. So you finally get square root 3 over square root 5, and that can be written as square root 3 divided by 5.
Perfect. This was actually the most complicated question. And when you see that you have square root x terms here, right? Square root x, square root x. We would like to have square root x there also. X approaches infinity. We have to get rid of this x some way or the other, right? So the best way is to think about writing this as 6 over 3. 6 over 3 can help you, right? Rather, 3 over 6, I should be saying. Sixth root of cube. So 3 over 6 is kind of half, and you get this square root of x. And that is why at this particular stage, you see we have a strategy. We squared the inside term, right?
Yeah.
And then outside we did like half, right?
Yeah.
So 1/3, 1/6, correct? It is exactly the same thing. And that is how you should be doing it. Perfect. So have a good look at this once again. This could be very helpful for all our viewers. Now, question number 10.
It was that part, the
Yeah.
cube root of 2x plus 1.
Yeah.
That part making into the sixth, I found a bit tricky.
It is extremely tricky. I have not seen anybody answering this question correctly so far in the test papers. Okay. So now you've got this strategy, and I hope all those who are watching this particular video will be able to solve such questions, right?
Yeah.
This question has been taken from, let me tell you, IIT JEE entrance examinations. So we have a technology entrance examination in India, which is extremely tough. So this question has come from that particular place. So yeah, it looks like a simple subject of limits. They think, what will they ask about? But this could be a simple looking question, extremely difficult to solve.
Yeah.
Yes. Now here is question 10 to 12. Can you answer these questions now? You have understood the concept in our discussion, right?
Yeah. So
Yes.
question 10,
Yes.
Given that the limit x approaches 0, f of x plus g of x exists, write functions f of x and g of x such that the limit as x approaches 0 of both the functions do not exist.
Yes.
So what you said was make f of x equals 1 over x, because at 1 over x, we learn with the reciprocal graphs, as x approaches 0, the limits do not exist.
Correct.
And we need to so if we got 1 over x as 1, we need to find what the other one is. So we're adding f of x and g of x.
Yes.
So when you add, so we have to make, let's say, make g of x minus 1 over x.
Correct.
And when you add them, you get 0, and 0 is a constant. So a limit exists. So
Yes.
that's the value. Yeah.
Brilliant. That's a good idea, and actually, it's a very difficult thought which could come in any test paper. So you should know about it. Otherwise, this simple question, simple looking question, could be the most difficult question in this test paper. Question number 11.
So with question 11, I took the, like, should I just read what I've written?
Yes, sure.
So I've got limit as x approaches 3, bracket limit as x approaches 3 f of x, bracket again cube root. So because we know that f of x equals 2, I'm trying to take that, like the thing that they've given, and make it as its own little factor. So once I get a nice formula, I can just sub the 2 back in.
Yes.
So then I get limit x approaches 3x squared divided by limit x approaches 3 f of x minus limit x approaches 3 of 5. So then I sub 2, so 2 cubed minus 3 squared over 2 minus 5. 5 is a constant, so it stays the same. Then that's 8 minus 9, which is minus 1. 2 minus 5 is minus 3. Minus 1 divided by minus 3 is a third.
You're right. Question number 12.
question 12. So, all right, I started off by sketching a graph, yeah. So the easy point to start with is f of -2 equals 2, because that's a clear point. So I just went to -2, went up to 2, and filled in the hole. Then I went, so limit as x approaches -2 from the left side, f of x equals 3. So that means it's a hole at -2, 3, and we want it to the left side. So you said just any line. That I didn't get. I thought it had to be a certain line. So I just did a horizontal line to the left.
That is also correct. Horizontal line is perfect.
All right. And then limit as x approaches -2 from the right side is 1. So I just go to -2, 1, put a hole, and do a horizontal line to the right.
Perfect. Both are correct. So there could be many different answers. Horizontal lines are very good because simple equation, you can say y equals to 3, where, you know, the value of x is less than -2. And then you can say y equals to 1, where x is greater than -2. So you also have the equations. So sometimes we have to write this as a piecewise function. Your horizontal lines is a better solution. Okay?
Yeah, okay.
Next question. Well, here's the solution of the previous one. Okay. Okay, this also, yeah. Now the next question is question number 13, right? Yeah, explain me, how did you do question number 13?
So, so we know, so what we're told in the question is f of x divided by x is 1.
Yes.
Right. So, but as limit as x approaches 0. So if you sub the 0 into the denominator, we're going to get 0, right? But you can't, that means the limit doesn't exist. But it says that it does because it's 1. So we need to, the only way we can get, for it to work, we need to make f of x 0, because 0 over 0 is an indeterminate form, which means the limit can exist.
Correct.
So it's 0.
You are right. That's a good explanation also. And part B.
So we just found out that f of x, so that part helps us with the second part.
Yes.
F of x we said is 0. So 0 divided by g of x. Yeah, so 0 divided by anything that's not 0 is 0.
Correct.
Yeah.
Question number 13 is done. Correct. So there's a different way of explaining, Amy, when we are saying this limit f of x over x is existing and it is 1 in this particular case. That really means it is a case of indeterminate, as you said. And that means that f of x has a factor of x. Once we cancel this particular factor of x, whatever remains, that function's limit is 1, correct? So what I did was I wrote f of x as x times h of x, right?
Oh.
Now when I write this, x and x will cancel. When I substitute 0, I say limit of h of 0 is 1, right? So I should have written 1 here. So limit of h of 0 is 1, correct? So that is how you get this answer of 1, correct? But as f of x is concerned, it is product of x and h of x. 0 times anything is 0, so we get 0. Oh, that was for product, right? So 0 times, look here, 0 times anything is 0, so the limit is 0. Perfect? It does make. So that is how we do. And as you said, once we know that the numerator is approaching 0 and denominator is some other value, then the answer is 0. Perfectly fine. So question number 14 now.
So with question 14, so we see an absolute value of x minus 1. So I just did the piecewise function, and I found, so you do minus x minus 1 where x is less than 1, and then you do x minus 1 where x is greater than or equal to 1. So left side, right side.
Okay, now we should not be writing equal to 1 because x minus 1 is in the denominator, so we have a restriction. So it may be a good idea to fill in here that x is not equal to 1, correct? Limit will exist because for limit, we don't have to be there. We could be very close, arbitrarily close. Now, move on.
So you're saying it's best to always write down the restrictions before we start, just so that we don't make up these mistakes.
Yes,
okay.
That's a good idea, yes.
Cool. Let me just write x does not equal to 1. Okay. Then I found the two sides. and you cancel the common x minus 1 factors. So on the left side, I got it as -3.
Yes.
And the right side, I got it as 3. So clearly, -3 is not equal to 3. So therefore, the limit does not exist. There's a jump discontinuity.
And you can actually sketch if you want to. Well, that is a part of the question. Sketch the graph and explain the discontinuity. So once you sketch, it is absolutely clear that this is the discontinuity, mainly because the limit exists from either side, but they don't match, right? So there is a discontinuity. There are two different values at x value given to us, correct?
Yeah.
The last question here is to find the quadratic equation. How did you do this particular question? Question 15.
So what I did was I just started with the simple. So they've given conditions, and the one that's the easiest for me to see was f of 0 equals 0. So all I did was sub in the 0 into the quadratic equation, and I got 0 equals 0 plus 0 plus c. So we know that c equals 0.
Correct.
Cool. Then we know, because it's a quadratic equation, we know it's a continuous function. So that's pretty much the key to unlock this problem.
Yes.
So you need to, so when we see limit as x approaches -1, f of x equals 3, we know that f of -1 equals 3 and f of 2 equals 6. So we've got our 3 points. Then you just use those values, sub it in, and I got 3 equals a minus b and 6 equals 4a plus 2b.
Perfect.
And I just did simultaneous equations, and you get b as, so you get a as 2, b as -1, c as 0. Is that what you thought?
That is correct.
Oh, okay.
So that is how you'll be doing it. And as you said, polynomials are continuous functions. Therefore, the value of the limit and the value of the function at that particular point is exactly same. And that helps us to identify 3 points on this quadratic equation. And so it's very easy to find the 3 unknowns a, b, and c, solving the 3 equations simultaneously. I think, Emma, you did a perfect job on this. Excellent. That was brilliant, actually. Yeah, that was brilliant. And you see, in about half an hour, you actually explained what you did. So definitely in 45 minutes, you could actually nail this test paper. And it was not an easy test paper to begin with.
It wasn't.
Correct? So now I like to understand, and if you would like to share with your own experience of attempting this test paper with others who are watching this video, what will you say?
So I would say, like you said in the beginning, always let's first scan all the questions and see which ones that you think you're going to get stuck on, and just remember them and be like, don't get all scared or anything. Just brush past and know that, go into the mindset knowing that you're going to encounter questions like this. But so when you do a quick scan of all the questions, you would know what strategies to use, what things that you've got in your head, and which ones you can use for each question. Some will be more obvious than others. Like when we saw some of the questions, if there's nothing else to do, you can always sketch a graph, make it visual to you, so it's so much easier to see. And when you get stuck on a question, don't spend so much time on it. Move on, because I also did it. And when I got to one of the questions, I was stuck on it, and I think I spent way too long. And by that time, if I was doing in time conditions, my time would have been up. But as I've seen with Mr. Kumar, I could have attempted the later on questions. So when you get stuck, just move on, and you can always come back. So perfect. That's my advice. Yeah.
I think that's a great tip, and many will benefit watching this video.
Yeah, right? Definitely.
Emmy, thanks a lot for all your contributions and summarizing this whole thing so well. Now, we have done our unit number 2, which was on limits, extremely important, and we have a good foundation to understand derivatives. We also know what are gradients and what are limits and how these things come together. So derivatives, which is the next unit, unit number 3 for us, we'll begin with that tomorrow itself. Okay. To give you a heads up, derivative is gradient, nothing else. So remember that part. It's a short form of writing, and we'll have a different notation. We'll just add f dash x, meaning this is the gradient. right?
Okay.
So you have already done quite a bit about it. So it was actually great that in about 3 lectures, to begin with, to get past all what you need to know about calculus, we covered in introduction. Then 2 lectures, we were able to do limits, and this brilliant test paper in the third lecture. So
Mm.
in 5 or 6 sessions till now, uh, of half an hour each, we could actually cover our first 2 units. That's a great going. But this could not have been done unless you would have watched, I should say, tons of my videos on each topic and practice.
Yeah,
So
obviously.
that's the key here, and you did it great. So now get ready for derivatives. I'll post some links for you. Watch them over so
Okay.
that you're ready for tomorrow's class, and we'll again try to do each topic fairly well, so that we could have at the end some brilliant test paper, which will have questions from previous test papers and some competitive exams. So in this test paper also, you had questions from competitive exams like GCSE, IIT JE, and many conducted here in Canada. So
All
I think,
right.
yeah, so I think you're good. Okay, so all the
Yeah,
best. I'm looking forward to tomorrow's session on derivatives.
me too. Thank you so much, sir. I really appreciate it.
Thank you. Bye for now.
Bye for now.